want to now graph exponential functions. So we got to show those 3 key points. So when we have an exponential function, we look at 1a, and a is the base of the exponent. 0, 1, negative 1, 1 over a. So you always need to know what that a value is. And then we're going to determine domain, range, and asymptote. And so when we're given these functions, there's going to be some transformations. So this one right here is x plus 1. So what we're actually going to do is we're going to move back to negative 1. Okay? And then this is going to shift us up 2. So what we like to do is kind of identify this new origin. So I'm going back 1, I'm going up 2. So at negative 1 up 2, this is my new origin. So that means that I have an asymptote that is going to go through my new origin, and all exponential are horizontal asymptotes. So my asymptote is at y equals positive 2. And then I have my 3 key points. And now, so what I need to know is the a value. And this 3 is attached to the exponent. So my a value is 3. So I'm going to now plot 1, 3, 0, 1, negative 1, 1/3. So from my brand new origin, not from the original, I'm going to go over 1, up 1, 2, 3, and then I have a little point there. Now it's hard to show points on this thing. There we go. There's an awesome point. And then 0, 1. It's the worst. So it's going to be tough to kind of show these points, but I'm going to do the best I can. How about this? I'm going to try something else. 0, 1. And then negative 1, 1 over 3. So there we go. There's, sure, that works. So those are my points, and now I'm going to just draw through them upward. Okay? So domain is going to always be negative infinity to positive infinity, and then the range starts at the asymptote, and it's always bottom to top. So the bottom part of the graph starts at 2 and goes on to infinity. Okay, moving on. So this one, the difference is that our a value is actually e, and e is 2.7. Okay, so that's really important to know, is that e is 2.7. So now, as long as you know 2.7, you can think that our points are going to be 1 instead of e, or instead of a, it's e. 1, e, 0, 1, negative 1, negative 1, 1 over e. So again, 2.7, 1 over so this is about 1/3. Okay, and then we want to identify what our shift is. And so our shift is x minus 2. And so what that means is that we're actually going to be shifting to the right 2. And then I'm not going up at all. So my new origin is over 2, up nothing. So 1, 2, here's the new origin. The asymptote is going to go through there. And then I'm going to plot my new points. All right, so my points, I'm going to go over 1, up 1, 2.7, and then 0, 1, and then negative 1, about 1/3. And then we go ahead, we just draw through. Okay. So the domain of this is our negative infinity to infinity. Range starts at 0 to infinity. And the asymptote is a y, because it's horizontal, equals 0. Okay, and with this one, the most important part, we've talked about this. My a value is 4. So the point would be 1, 4, 0, 1, negative 1, 1 over 4. But, huge thing, this right here is a game changer. This is going to change every single y value. So now I'm going to take this, and this, and this, and I'm going to multiply every single y value by 2, because this is showing I will have a stretch. All right, so my points are actually going to be 1, 8, 0, 2, and then -1. 2 times a fourth is 1/2. Whoa, that's supposed to be half. So that's what you would plot. And then this is shifting me back 3 and down 5. So back 1, 2, 3, down 1, 2, 3, 4, 5. There's the asymptote through there, that's horizontal. And then the points are going to be, like we mentioned, just make this a little bit bigger, are going to be over 1, up 8, 0, 0, 2, and -1, 1/2. And then you go ahead and grow that up. And then domain and range and asymptote you guys can do. Okay, so I'm going to go through a log function. Now, a log function, this is actually going to be a natural log, that's all we'll look at. But a natural log function is the inverse. Okay, so that's kind of key to know. Oh, sure, key, inverse. So the reason that that's super important is because now instead of 1e, we're actually switching everything. So my main points are e1, 1, 0, 1 over e, -1. So every single point that I'm going to plot, or that my 3 key points, are always going to be determined with this, unless I have a stretch or a flip or something like that. Okay, so what's happening for number 16, this is going to move me back 1 and down 4. So my new origin is -1, -4. So I go -1, 1, 2, 3, 4. There's the new origin. And then now that I have a complete inverse function, I no longer have what we see as that horizontal asymptote. I now have a vertical asymptote. So that is going to go directly through the new origin. And now I'm going to plot my 3 key points. And that starts from my new origin. So I'm going to go over E, which is 1, 2.7, up 1. Wait, sorry, hold on. Before I do that, I'm sorry, I showed my new origin. Here's my shift, here's my shift. This, so important, that is going to be changing every single y value. So I'm going to go ahead and I'm going to multiply this and this and this by +2. So my key points for this one are going to be E2, 1, 0, and then 1 over E, -2. Because, oh, I'm sorry. 1 over E, -2. Anyways, and now I'm going to go ahead and plot these. So we're going over 1, 2.7, up 2, and then over 1, 0, and about a third down 2. Okay, so we did our shifts, and then we have this nice little stretch here. And you should not be going over the asymptote ever. That's a total no-no, but hard to draw on this. And then the domain is going to be now from your vertical asymptote. Starts at -1 to infinity. The range now switches. This range is now always negative to positive infinity. And then the asymptote is always going to come from here if you were to set that equal to 0. And that's x equals -1. So I'm not going to do this one. You can look online, but this is a flip. So what you would do is take your points and then make them all negative because of the flip. You're not shifting left or right. You are just shifting down 2. I did tell you guys that you can skip number 18. I have it on the solution key, but don't worry about this. We didn't talk about it. If you have a negative within your argument, it's going to flip basically every single x value. So no worries about understanding that. Okay, so these ones I'm going to do like one of each. So here we are converting, okay? So if I'm converting, then I'm going to have to understand the base of my exponential function, and then I'm going to switch. So I always start with the base, and then I take this number and I switch it with this side. Okay, so rewriting this as a log, I have log base 3, which is a subscript, and then of 243 equals 5. Now this one though is different. I'm not going to write log because when I see e, I know that that's natural log. And then the base is e of 12 equals x. All right. Now when I'm going from a log to an exponential, I'm going to understand the base. The base is 3, but now that becomes the base of the exponent. So 3, 4 equals 81. So 3 to the 4th equals 81. When you don't have a base there, you need to know the common base. So the common base of natural log is e. The common base of log is 10. So e to the 0 equals 1. 10 squared equals 100. Okay, and then finally, last thing is going to be solve. All right, so here's a good one because the base really isn't here, and I have to solve for x, and x is up in that exponent, so kind of hard to do. So this one you want to rewrite exponentially, but again, you have to remember that the base is actually e, and then this is called the argument. So I rewrite this e to the 12th equals e to the x. E to the 12th equals e to the x, and since these are the same, they're gone, so x equals 12, and that's my answer. 2 to the what equals 64. Let's see, last page. Okay, 2 to what power equals 16? 1/5, this one's tricky. 1/5 to what power equals 25. So when you are given this expression, that's the question you want to ask yourself. The base to what power gives you the argument? But if you don't know how to set that up or answer that question, you can always set it equal to x and then rewrite it exponentially. So that's essentially what I did. Okay, 1/5 to x equals 25. But I want to change this. So instead of 1/5, I don't want a fraction. So if I push this 5 up, what's going to happen is my exponent's actually just going to become negative. And then I'm going to rewrite 25 so it has a base of 5. So 5 squared is 25. And now that they're the same, I just focus on the exponents. So x equals -2. Okay, then you can kind of look at the rest. I thought you guys did a nice job, so you can look at the rest online because it's all really similar. This you just have to factor. Okay, so 4 to the 2nd equals this, so 16, move it over, factor, but just check your answers. All right, make sure you guys do math lab as well, please.